example 3, we're going to solve using logs. We're going to utilize the properties of logs that we did in the last section, 6.5, to help us maneuver our variables out of the exponent area and down back onto the ground level. And you'll see what I'm talking about. It's a little involved and a little tricky, but I want you to try to do your best and follow each step. And if you can conceptualize each step, ultimately you should be able to replicate the process. All right, so we are trying to solve 3 to the x plus 1 power equals 5 to the x. So we're trying to solve for x. Okay, our first instinct should be, like example 1, we should try to say, can we make a common base? Because then that will make it so much easier, then we can just set the exponents equal. But the problem is we have a 3 and a 5. So, no, right? There's no way, we don't have numbers like 2 and 4, or 8 and 16, or 3 and 27, like things that we know we can express as the same base. So 3 and 5, no relationship, so we can't use a common base. But here's the problem, is we need to get x out of the exponent spot. We're not good at solving when x is there. We need to bring x down to the ground level. Well, we need to ask ourselves, how can we just take our exponents and get them onto the ground level here, right? How can we do this? Well, if you remember things about properties of logs, is that exponents can slide to become coefficients and vice versa. So you are allowed, just like you are allowed to multiply by 4 on both sides or add 6 on both sides, you can introduce a log on both sides. And the easiest log to introduce is just the common log, log base 10. So all we're going to do is introduce log on both sides, which as long as you do it on both sides, you are preserving the equality of the equation, and you're allowed to do it. You're allowed to introduce logs. Okay, so now that we have this as a log, now we can take our property that says exponents can slide to become coefficients. So now we have x plus 1 times log 3 equals x times log 5. Okay, this is where it gets a little tricky. I just want you to stay with me here. As long as we can understand introducing a log and then utilizing the properties, that's the thing, guys. It's a puzzle. Is we have to figure out what clue do we need? What can we introduce? What can we change about this to make it work the way we want? So introduce a log. All right, here's where it gets a little, I don't know. All right, we don't like having the x in the parentheses. We want to break it out of the parentheses, so we're going to distribute. So we have x times log 3 plus 1 times log 3, which is just log 3, equals x times log 5. Okay, the best thing to do is to get all of your x's on one side. So I'm going to subtract x log 3 from both sides. Again, just trying to kind of, that's usual equation solving, is we want to get all of our x's on both sides. So now we have log 3 is equal to x log 5 minus x log 3. And what you should notice, right, hopefully, is that you have two terms, and they both have an x. So we'd really like to factor out that x. So if we factor out an x, we're going to be left with, well, if you divide off an x, you're going to be left with log 5. And if you divide out x, you're going to be left with log 3. So now our x is isolated. And now we can just divide off this piece here on both sides. Look at this. It crosses off. So what we're left with is log 3 divided by log 5 minus log 3. And look at that. It's equal to x. Now, you can leave it like this, or since they're all common log, we can actually, we can actually divide. So personally, this is what I would do, is if you really want to get fancy and be exact, so I would do this first. I would do So in my calc, I would do log 5 minus log 3, log 5 minus log 3, and then I'm not going to round it because I had that answer. And if you're using a graphing calculator, which hopefully you have, right? I mean, you can always round, but we're trying to be exact. So now you can do log 3 divided by the most recent answer. So you can do log 3 divided by second, which is the minus sign. So anyways, you get 2.15. We'll go with 2.15. But I like to get it in at least some approximate answer because then at least we can check it, right? So again, you can leave your answer if it asks you to leave it in exact terms. This would be exact. But so we're going to just check, let's check 2.15. So remember our original was 3 to the x plus 1 equals 5 to the x. So 3 to the 2.15 plus 1 equals 5 to the 2.15. So does 3 to the 3.15 roughly equal 5 to the 2.15? So 3 to the 3.15, we get 31.837, and 5 to the 2.15, 31.826. I mean, yeah, with rounding, absolutely. So we get 31.8 equals 31.8. And again, you just want to check it. I mean, honestly, if you solve a puzzle, you want to see if you did it right. So hopefully, again, you can introduce logs as it helps you. You can do it like any other operation. Try to get your x's on both sides. Do a little factoring. I know that might get a little messy in the middle, but as long as you get an answer, always go back and check it. And then, hey, it checked out, so we did a nice job.